Hey guys, welcome back. So we're back doing some Lewis structures. We're first going to do it for this compound here. And in this one video, I'm going to write down the rules as we go through each of them. So the first thing we're going to do is we're going to count the number of valence electrons. And the periodic table is going to help us out here. So everything here is 1, 2 valence electrons. We just forget about this little middle area, the transition metals. 3, 4, 5, 6, 7, and then 8 valence. Cool. So we're counting the total number of valence. Here we have hydrogen. Each hydrogen has 1. Since we have 2 hydrogens, I'm going to add that 1. Carbon, which has 4. And oxygen, which has 6. So we have 12 electrons total, and we're going to spend those electrons in different ways. Before we draw out the structure, we need to identify the central atom. And the central atom is going to be the least electronegative atom. So how do you know which is the most and which is the least electronegative atom? I'm going to go over this a little bit more in my video later this week, but everything in the top right corner here, this is where this arrow is pointing to the most electronegative. Stuff over here in the bottom left corner is the least electronegative. What if, though, you are in a place where you have oxygen in one atom and chlorine in one atom? How would you decide which is more electronegative since they're both 1 away from fluorine? This is where I have a really helpful mnemonic for us. So I'm going to write it in this top corner, which I'm going to write right here. We have a fake word, Fonkelbrish, where it lists all of these atoms in order of most to least electronegative. Can you tell which end is the most electronegative end? Hopefully you're thinking fluorine, right? So fluorine is the most electronegative end of Fonkelbrish, and hydrogen is the least electronegative end of Fonkelbrish. Fonkelbrish is super helpful because it contains most of the atoms that we'll be using in Lewis structure. So stuff like this, we don't really use in Lewis structures. Atoms like down here, maybe you'll see every now and then, but stuff up here is really the most common. So that's why it's so helpful. And we're going to use it in all of our videos today. If we were using Fonkelbrish, we'd say, oh, okay, the least electronegative is hydrogen. Is that possible to have hydrogen as your central atom? No, except hydrogen, right? Hydrogen can only hold 2 electrons or 1 bond, so if it was hydrogen was a central atom, this would be impossible because then hydrogen would have 6 electrons. It does not like that. It likes to have 2 electrons, so hydrogen can never be the central atom. This means that our central atom has to be carbon, and that's okay. Put carbon here. We have an oxygen, hydrogen, and hydrogen. Cool. Now that we know what the central atom is, we're going to add bonds to the term. I'm going to call these the terminal atoms. The terminal atoms are the atoms at the end. So 1, 2, 3 bonds. And remember, 2 electrons per bond. So we start out with 12 electrons. We just made 3 bonds. So we use 1, 2, 3, 4, 5, 6 electrons. And now we have 6 electrons left over. The next step we're going to do, so how are we going to spend these 6 electrons? We're going to use leftover electrons to make sure that these terminal atoms have their octet filled. So let's go ahead and spend them. So hydrogens are okay. Remember, hydrogens are one of the exceptions. They're chilling, having 2 electrons. Each bond is 2 electrons, so they're having a great time. So we can go ahead and spend our electrons here. So right now the oxygen already has 2 electrons from this bond. 3, 4, 5, 6, 7, 8. So we just spent 6 electrons on that oxygen, so we have none left over. And we always need to double check. Check to make sure that the central atom has its octet filled. Right now we see carbon only has 1, 2, 3, 4, 5, 6 electrons. That's not going to cut it. Carbon wants its octet filled. If you don't pass this check, this is when you would make a double or a triple bond with lone pairs. Make space for us. With lone pairs. So I'll show you what we mean by that. So right now we agree oxygen has its octet filled, carbon does not. So what we do is we erase a lone pair and we reuse that lone pair to make a double bond with the central atom. So now carbon has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. Let's check for oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So we're good. So this would be the Lewis structure for this guy. So I hope that you guys have a better understanding of how to do this and when it's appropriate to put a double bond.